Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences ITB. So we are still going to discuss additional applications of the derivative with special focus on the sketching of curve today. So this is the last part of this week. So let's begin the topic of sketching curve. Before we begin with sketching curve, I would like to discuss about horizontal and vertical asymptotes. So before we get to the last, okay, yeah, we review about the asymptote. So this is what we usually call the horizontal asymptote. So it at x goes to at x goes to minus infinity. When x get smaller and smaller, it will go to some value, some height of some height, that is 1. So we usually call the y equals 1 is the horizontal asymptote of this function. The same, yeah, for this, when x goes to infinity, it will go to the height 1. Okay, so y equals 1, the height 1, is the vertical asymptote. Okay, and this is the horizontal asymptote, and this is the vertical asymptote. So when x goes to 2, when x goes to 2 from the right, it will goes to plus infinity. Okay, yeah? Or when x goes to 2 from the left, it will goes to minus infinity. So we usually call this the vertical asymptote, and this is the horizontal asymptote. So the definition will come follow. Okay, okay, yeah. Do you remember how we can find the asymptote without looking at the graph? No, okay. So our problem is finding the asymptote without looking at the graph. So the line y equals b is called the horizontal asymptote if limit fx x goes to infinity. So the value of this when x getting bigger is big and bigger will become b. Okay, and when limit x when x getting smaller and smaller, the value of f, the height, will go to b. So we usually call this y equals b is the horizontal asymptote of fx. Okay, of course, in general, the horizontal asymptote for x goes to infinity and x goes to minus infinity in general is different. Okay, in general is different. Okay, so what about a vertical asymptote? So x equals c, as you have already seen and at the previous example, is called the vertical asymptotes of fx if limit fx when x goes to c plus is infinity, or limit fx x goes to c plus is minus infinity, or limit fx when x goes to c minus is infinity, or limit x goes to c minus of fx is minus infinity. So if you have either this, or this, or this, or this, x equals c is we usually call the vertical asymptote of f. Okay, yeah? Let's see for the example. Find the vertical and horizontal. Find all the vertical and horizontal asymptote for the function f. So for the first one, we look at the function f. When we look at the function f here, we divide by the highest derivative. Oh, okay. This is wrong. Yeah, it should be divided by x squared. And if we divide by x squared, this is 1 minus something, and this is goes to 0, and it will give you infinity. Okay, yeah, this is still wrong, but it's okay, you can correct it. Okay, so in this one you don't have horizontal asymptote. The second one, if x goes to minus infinity, it goes to infinity also. Okay, this is still wrong. Okay, and this is still wrong. It goes to plus infinity also. So, but this is right, yeah. It is infinity, and this is infinity. This is right. The result is right, but the process is not. You can correct it by yourself. Okay, so in this case, we do not have horizontal asymptote. Okay, yeah, because it doesn't get closer and closer to some value that is real. Remember, infinity is not a real number. Infinity minus infinity is not a real number. What about vertical asymptote? We can just look when x goes to 1 from the left of 1 or from the right of 1. You can choose either. And this one, we look at minus 1 plus. And if we look at minus 1 plus, you know that it will become positive at the numerator, but for the denominator, it will become larger and larger. Yeah, the fraction will become larger and larger if you x goes closer to minus 1 from the right. So it will go bigger and bigger, so it will have infinite. Okay, yeah. So x equals minus 1 is the only vertical asymptote. Okay, yeah. Technically, how do I, if I have a fraction, how do I find the vertical asymptote? Just look at the zeros of the denominator. Okay, yeah. Okay, you have to find the vertical and horizontal asymptote of this. Okay, yeah, as you can already expect, the horizontal asymptote is given by 1, and the vertical is 3. Try to confirm my intuition, eh? And the second one, the vertical asymptote is 2 and 3. You have to prove. And the horizontal asymptote is y equals 0. Okay, yeah. Try this on your own. Okay, after this, we will look at the curve sketching. Okay, to sketch the graph, we need to find this: the domain of the function, the range of function, but this is optional because sometimes it is very hard to find the range of a function. Find points in the graph. It can be x-intercept, y-intercept, or other point. It is okay. Find the interval of monotonicity, interval of concavity, all asymptotes of f if they exist, and then finally sketch the curve based on all information above. Okay, sketch the graph of the function of this. X to the power of 4 minus 2x squared plus 1. Okay, the first one is the domain. The domain is all real. Okay, because this is continuous at all real. So the domain is all real. The range, but it cannot easily determine, is okay. The y-intercept is y equals 1. How do I find this? You set x equals 0 and you have y equals 1. But the x-intercept is not easily determined. Yeah, okay. The next is interval of monotonicity. F prime is given by this. You can factor out x, 4x, and you can factorize this, and you have this. So the zeros is given by minus 1, 0, and 1. How do I find the interval of monotonicity? I have to find the sign diagram. I have this, the sign diagram of F prime. So I have decreasing, increasing, decreasing, increasing. So I have it is increasing at this interval and decreasing on this interval. And by the first derivative, we know the relative minima is happen at minus 1 and 1. And the relative maximum is at 0. Okay, yeah, you can easily see that. And interval of concavity, I have this. I can factor out 4. I can factorize this using this. So the zeros is given by this. So how do I find the interval of concavity? The same. I can draw the diagram. Don't forget, this is the sign diagram for f double prime, but this is the sign diagram of f prime. Be very careful. Be very careful. So by using the previous, we know that the function is concave upward at this point and this point. Okay, so this is concave upward, concave downward, concave upward. Okay, and the inflection point is given by this one. This changes concavity, changes concavity. So both minus 1 over square root of 3 and 1 over square root of 3, both are the inflection points of this function. Okay, after that, since f is not a rational function, there are no asymptotes. Okay, combining all the information above, we can sketch the graph as follows. Okay ya. So this is decreasing, increasing, decreasing, increasing. Okay ya. What about the concavity? What about the concavity? It concave upward at this point, concave downward at this point, and concave upward at this interval. Okay, you can check. You can check by yourself. Okay, the second one, we want to try to sketch this curve. X divided by x plus 1 squared. Okay, the domain it must be R, but minus 1 is not included because this is a rational function. And RF is from minus infinity to infinity. But I think 0 is not included, yeah? 0 is not included. No, 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 it is included. Okay. Okay. And then the y-intercept when you set x equals 0, and you have when x equals 0, you have 0. Okay. So it intercept at the origin 0, 0. The x-intercept, yeah, the same because this is the origin, the intercept, yeah. So the interval of monotonicity, you have to find the derivative of this. And the derivative of this is given by u divided by v is u prime v minus uv prime. You can plug in the formula and you can simplify the numerator and you have this. So the interval of monotonicity, the zeros is given by 1 and minus 1. How do I find okay, yeah, the zeros of f prime? Okay, stationary point is x equals 1, but it can still change signs at x equals minus 1. Okay, yeah. This is minus 1 and 1. It can change sign at minus 1 and 1. So I have by plug-in some point to test for the f prime. So you have decreasing, increasing, decreasing. So the function f is increasing at minus 1 and 1, decreasing at this. Okay, yeah. It has relative maximum at 1, but I don't know at minus 1. Why? Because this is not defined at minus 1. And we can further see that this is the vertical asymptote, yeah? So it doesn't have a relative maximum at minus 1. Okay, what about the interval of concavity? I want to find the second derivative using the same formula. You can find this. Okay, yeah, the zeros is given by x equals 2. Okay, this, so the stationary the zeros is x equals 2, but it still can change signs at x equal minus 1. So I can do the diagram for f double prime. So this is the sign for f double prime. Concave downward, minus minus plus, downward downward upward. So upward when interval this, downward at interval this. Just one inflection point, that is at 2, because at minus 1 it doesn't change concavity. Minus minus. Okay, yeah. So the asymptote, x equals minus 1 is the asymptote. Why? Because I want to if the right hand limit of this, or when x goes to minus 1, is minus infinity. So it is sufficient for us to say that the x equals minus 1 is the vertical asymptote. Okay, yeah? You can check limit x goes to infinity of fx is 0 and x goes to minus infinity, and this is also 0. Okay, so y equals 0. Y equals 0 is the horizontal asymptote, and x equals minus 1 is the vertical asymptote. Oh, this is wrong, yeah? Y equals, okay, okay, okay. Okay, so combining all the information, we can sketch the curve as this one. Okay, yeah? So this is concave downward, concave upward, concave concave downward. Sorry, upward. Upward, yeah? Downward, downward, upward. Okay, yeah? Maximum here, decreasing, increasing, decreasing. Okay, yeah, I think there's some inflection point here. Yeah. Oh, okay, at 2, yeah, there is an inflection point. Okay, you have to try on your own to sketch this curve. So we have end our lecture for this week that is on curve sketching. Thank you very much.